A small home energy system does not create unlimited electricity from nowhere. It works by capturing, converting, storing, or redirecting energy. And the difference between those functions determines whether the system is genuinely useful or merely sounds impressive. That distinction matters because most people first look at the physical size of the device. They assume a compact unit must either be revolutionary or too small to matter. But size alone tells you very little. The real questions are where the energy comes from, how much power the system can deliver, how long it can deliver it, and which household devices it is expected to support. This becomes especially important during a blackout. When the grid goes down, a household rarely loses just one convenience. Lights stop working. Refrigeration becomes uncertain. Internet equipment shuts off. Phones eventually run out of power. Depending on the season in the home, heating or cooling may also be affected. People often respond by trying several logical solutions. They reduce electricity use. They unplug devices. They buy flashlights, battery packs, or a portable generator. They may even investigate solar panels or larger backup systems. But each option creates another question. How much power is actually needed? How long will the outage last? Which appliances are essential? Can the system operate indoors? Does it require fuel, sunlight, charging, maintenance, or professional installation? This is why the phrase home energy system can be misleading. It does not describe one single technology. It can refer to a battery, a generator, a solar setup, an inverter, a power management device, or a combination of several components. To understand how these systems work, it helps to separate the visible device from the invisible structure behind it. The visible part might be a compact box mounted on a wall, placed on a shelf, or connected to selected appliances. But behind that box are several different jobs that must happen in sequence. First, the system needs an energy source. That source might be electricity previously taken from the grid, energy collected from solar panels, mechanical energy converted into electricity, or fuel used by a conventional generator. A storage device cannot provide energy unless it was charged. A generator cannot keep producing electricity unless it has a continuing energy input. Second, the electricity may need to be converted. Many batteries store direct current, while common household appliances use alternating current. An inverter changes the electricity into a form those appliances can use. Other components regulate voltage and help prevent the connected equipment from receiving power in an unstable form. Third, the energy may be stored. Storage is what allows the system to provide electricity when the original source is unavailable. But storage introduces a major limitation: capacity. A small battery may keep phones, lights, or communication equipment running for a useful period. That same battery may struggle with appliances that demand large amounts of power. Fourth, the electricity must be distributed. Some systems power only the devices plugged directly into them. Others connect to selected household circuits. Larger installations may support more of the home, but that usually requires additional equipment and a more involved setup. Finally, the system must manage the load. This is the part many people overlook. Appliances do not all consume electricity at the same rate. A light, phone charger, refrigerator, microwave, space heater, and air conditioner place very different demands on a power system. Some appliances also require a brief surge of power when they start. A refrigerator, for example, may consume a moderate amount while running, but demand more electricity during startup. A system that appears large enough based only on average consumption may still fail if it cannot handle that momentary surge. This explains why the advertised power rating and the stored energy capacity are not the same thing. Power describes how much electricity the system can deliver at one moment. Energy capacity describes how long it can continue delivering electricity. A system may have enough output to start an appliance, but not enough stored energy to run it for many hours. Another system may contain substantial stored energy, but be unable to support a high-demand device. The real issue isn't whether the system is small. It's whether its source, output, capacity, and intended load match the situation. Once that becomes clear, the conversation changes. Instead of asking whether a compact system can power a home, the more useful question is which parts of the home it can support. Keeping several LED lights, a phone, a router, and essential medical equipment operating is a different task from powering an electric stove, central air conditioning, a clothes dryer, and every household circuit at once. This does not make smaller systems useless. It gives them a more realistic role. A compact energy system may function as an emergency layer rather than a complete replacement for the electrical grid. It may provide enough power to preserve communication, maintain basic lighting, or support selected low-consumption devices. In some configurations, it may help reduce the amount of electricity drawn from the grid. But that depends entirely on the system's actual design and energy source. Claims about dramatic bill reductions require the same careful analysis. A device can only reduce grid consumption if it supplies energy that would otherwise have been purchased from the utility. That means the energy must come from somewhere else, such as solar generation or another external source. Charging a battery from the grid and later using that electricity does not automatically reduce total consumption. It mainly changes when the electricity is used and some energy is lost during conversion and storage. That does not mean every savings claim is false. It means the mechanism must be explained. A credible explanation should identify the energy source, continuous output, surge output, storage capacity, expected runtime, supported appliances, charging requirements, safety protections, and installation method. Without those details, it is impossible to judge performance from appearance or marketing language alone. Think of a home energy system as a water tank connected to several faucets. The size of the outlet determines how quickly water can flow, while the size of the tank determines how long the flow can continue. Opening several large faucets at once may exceed what the system can provide, even when the tank is full. Electricity behaves differently from water, but the comparison reveals the central idea. Output and duration are separate limits. For most households, the practical starting point is not trying to power everything. It is understanding priorities. Which devices protect safety, communication, food, medication, or basic comfort? How much electricity do those devices require? How long might they need to operate? A home energy system becomes easier to evaluate when those questions come before the product. The technology itself is only one part of preparedness. The deeper value comes from understanding what the system can do, what it cannot do, and how it fits into the household's actual needs. There is a structured breakdown in the description for anyone who wants to examine these systems more carefully. Subscribe for more practical explanations of home energy, backup power, and grid independence. A reliable decision begins with understanding the system, not believing the headline.